So good morning everybody, myself Acharya Vishvendra, and today I'm going to uh, start a video. It's basically a sort of one short lecture for some topics of modern physics. So let's start. So the first topic that we are going to do is photoelectric effect. So as you know that photo stands for light and electric means for electricity. So talking in a layman language, when there is electric current produced due to impact of photons or light, then that effect is called the photoelectric effect. This effect was observed by Henrik Hertz when doing experiments on conduction of electricity through gases in vacuum tubes. And he just observed that the sparking between the electrons increases substantially when the cathode was irradiated with UV rays basically. So that showed that somehow UV radiations facilitated the emission of electrons from the emitter or the cathode. So from there the concept came, and then experiments were done by Henrik, uh, this Holwach and Denard, and its explanation was done by Sir Albert Einstein in 1905, for which he got Nobel Prize in 1929. So this is a brief historical introduction about this. Let's study the concepts over here. So suppose this is the metal plate, and on the metal plate there are electrons. So when photons fall on these electrons, they are emitted. They leave the surface of the metal if they have sufficient kinetic energy to overcome the work function. We name these electrons as the photoelectrons. So we'll study in a very optimal to the point way. So the first point is conditions for photoelectric effect. So the conditions are that energy of the photon should be greater than the work function of the metal. And this can be equivalently said that frequency should be greater than the threshold frequency. And the same expression reduces to wavelength should be less than the threshold wavelength. So as per the first condition is concerned, we have three cases. Energy of photon should be greater than work function. Second condition is frequency should be greater than threshold frequency. And third is wavelength should be less than the threshold wavelength. Now let's study point number 2. So point number 2 is the relation between these things. So the work function is related to the threshold frequency by phi naught is equal to h mu naught, which is ultimately related to the threshold wavelength by hc by lambda naught, which reduces to 1240 electron volt angstrom by lambda naught. This can be used